My name is Eric Kostlin, Technical Marketing Engineer for Cisco Systems. I will present and demonstrate how the Cisco Secure Firewall utilizes Snort 3 for active authentication and to analyze HTTP2 traffic. Active authentication for web traffic is something that we're all familiar with, where a web server sends an HTTP 401 response, which is an authentication request. Now, firewalls like the Cisco Secure Firewall can spoof this response and force active authentication for any website. In this way, the firewall can learn the identity of the web user. This is called active authentication. It contrasts with passive authentication, where the firewall learns the identity of the user without interacting with the web client. Here's an example, and this is actually from our product. You can see the URL that the firewall is using to do the active authentication, and notice the default port 885. Note there's a difference between client authentication and user authentication. The client, the web browser, for example, might have the credentials cached, and therefore the user may not see that pop-up. Now, one of the challenges to active authentication is that the web traffic is encrypted, so we have to somehow get that authentication request injected into the web traffic using some sort of man-in-the-middle approach. Also, we have to be able to support TLS 1.3 since that is becoming more popular. Also, HTTP2 is replacing HTTP 1.1. Then traditionally you would downgrade to do the active authentication and the analysis of the web traffic. But because of such technologies as HTTP strict transport security, that downgrade is becoming impossible in some cases. And just as a reference what we're talking about, notice that about 2/3 of the traffic in 2020 was HTTP 2 versus HTTP 1.1. And Snort 3 is what's going to allow us to do the decryption of the TLS 1.3 and to do the analysis of the HTTP 2. Note that you wouldn't want to downgrade if you can avoid it, because one of the big benefits of HTTP 2 is the request multiplexing, which allows multiple HTTP requests to be done in parallel over a single TCP connection. And the web client can specify priority strategies for those streams. Thus, you can build a web page that has many components quite efficiently. Also, there's header compression and some binary format rather than a string text. This takes care of a lot of issues that come up with special characters. Let's look at the process of active authentication. So the client will send a web request to some web server. It'll be intercepted by the firewall. The firewall will check its cache to see if it recognizes the client IP address and can associate it with a user. If not, the client will send a 307, a temporary redirect, telling the client to go to a different website. That 307 looks like it's coming from the web server, and it's redirecting the client to the inside interface of the firewall. The client sends an HTTP request to the firewall to that inside interface, and now the firewall can send back a 401 asking the client to authenticate. Authentication is done with an authentication server, either Active Directory or Open LDAP, and that authentication traffic actually goes through the firewall. Upon successful authentication, the user IP mapping is added to the authentication cache on the firewall. Now, it's a matter of the policy whether the traffic should be allowed. If the traffic is to be allowed, the firewall will send another redirect to direct the client to the target web server. Let's proceed with the demonstration. At a high level, what we're going to be doing is creating an FQDN object. This FQDN will point to the inside interface of the firewall. You then have to create or modify an existing identity policy to include active authentication. You have to identify a realm that you're going to use to do the authentication. You're going to have to upload a certificate for the relevant firewall interface, and you're going to have to reference that FQDN object in the identity policy so that it will populate the redirect with that FQDN. You then have to create or modify an SSL policy to handle the decryption of the traffic, because this is most likely to be HTTPS traffic. And you must modify the access control policy. You have to reference the identity policy and the SSL policy in the access control policy, and you have to allow the redirect traffic to the firewall. So here we see the Firewall Management Center. Let's add a network object. This network object is going to be the inside interface of the firewall, and we will give it an FQDN that the client can resolve. Now let's look at the identity policy. In this case, I already have an identity policy, but it doesn't have active authentication in it. So let's modify it. Let's configure active authentication for this policy. So we have to select a certificate. We have to use that FQDN as our redirect for our 307 message. Notice we'll keep the port set to 885. And now let's add a role for active authentication, saying what traffic we want to authenticate using active authentication. For purposes of the demo, we'll use all traffic. And we have to specify the authentication realm that we're going to authenticate against, and the choice of authentication protocol. We'll just stick with basic. And there we have it, but it isn't quite right. We're going to prefer passive over active. Now, in a production environment, we might like this. We'll say we'll try passive, and we'll only go to active if passive fails, if we can't identify the client without active. But for purposes of the demo, let's just always do active. Notice it's warning us that we're preempting that passive role, but that's okay for what we're trying to do today. Generally, you would choose which traffic you want active, which you want passive, and which you want passive to fail to active. Let's go to the SSL policy. And here, we already have an SSL policy. This is a very typical SSL policy that we have. We have some exemptions for traffic we don't want decrypted, and then we decrypt the remaining traffic. So this looks good. I just want to note that we're going to use a certificate signed by VeriFraud to do the decryption. Let's go to the access control policy. Notice we are already referring to the identity policy, so we don't have to change that, but it doesn't look like we have an SSL policy. So let's choose that demo SSL policy. And then what remains is to add a rule to allow the redirect traffic. We can trust it. There's no sense analyzing the redirect. And just to make it clear, particularly for troubleshooting, let's put it way at the top. The traffic's going to be coming from in zone 1, as it turns out. And it's always going to be going to the inside interface of the firewall. So I'll put that as a destination network. As far as the port, this is TCP port 885. And let's add that. And there we go. We've modified the access control policy as needed. Let's deploy the changes. As you can see, the access control, SSL, and identity policies have been modified. We'll deploy these changes, but we won't wait for it to be deployed. Let's look at the user experience here. So notice we don't have any active sessions yet. Let's get the user going here. He tries to go to a website and he's asked to authenticate. If we look carefully at the HTTP headers, we'll see the 307 redirect and the 401 authentication coming from the firewall. We authenticate, and we're allowed to go to the website. And you can actually see the second redirect and all of the communication with the website. Now, if you look at the certificate, you'll notice that this is not the certificate for Cisco.com. This is the certificate signed by the authority that allows us to do the man in the middle. Back to our management center, we'll see that we have Rita using active authentication. This will remain until the timers time out or we log out manually. Thank you very much for your time.